So we're looking at the iGCSE Edexcel 1 to 9 2018 June paper. Question 7 involves section 1b motion, section 4c which is work, energy and power. So formulas as usual, so have a little think of what you need, the rest you've got to learn. So let's see what we need. So from the diagram here that shows a coin being dropped from a height, and the graph obviously there shows how the velocity of the coin changes until it hits the ground. State the equation linking acceleration, change in time, change in velocity in time. So let's see what we've got. So it should be acceleration is change in velocity over time taken. Really important to see that change there. Okay, change in velocity, and not just velocity, because clearly if it was a formula, it would be A is V take U, final take initial. Very important to get that in. So the coin hits the ground in a time of 0.62 seconds and with a velocity of 6.1. So that's just literally on the graph in front of you. I want you to calculate the acceleration of the coin as it falls and give a unit. So 3 marks, relatively straightforward, but some people struggle. Substitution, evaluation and a unit, that's what's required. So let's see, we've got acceleration is 6.1, take 0 because the difference was 6 and we started at 0. We divide it by the time, 0.62, gives me acceleration of 9.8. They would accept 10, 9.8387. And the units wise, meters per second squared, or meters per second minus 2, or meters per second, because you took meters per second and divided it by seconds. Very easy. Learn the units for acceleration. Makes a lot of difference. That's an extra mark, isn't it, that you could miss. Part 3 and 4. Let's take the feature of the graph that shows acceleration, while it's the gradient or the slope that you worked out. Calculate the height from which the coin was dropped. Use the graph to help with your calculation. Use the graph, it tells you. Okay, 3 marks. I've got the graph again. Let's have a look and see what we do. It's asking that the height is the area under the line, seen explicitly or implied. You've got to show that you're doing it. So somewhere along the lines I need to see half times the base times the height of the triangle, and then an evaluation of it. So let's see what we've got. We've got height then is the area of the line. So in this case, a half times 6.1, which I read across, 0.62, which is down, and it has to be exactly that. You can't do 6, you can't do 0.6. The height then should be 1.9. They allowed you a range, because you're reading off a graph, of 1.88 to 1.92. I think that's quite straightforward if you've learned the stuff in class. Now a long answer question. A ball is dropped from a very large height, so it's really high up, and the graph shows how the velocity of the ball changes just before it hits the ground. So we need ideas explaining why the velocity of the ball changes in this way. Refer to ideas about forces in your answers. So you've got to use that graph and you've got to use forces. If you don't talk forces, you're not really going to get much. Now there are actually 7 marking points. I'm going to put them all up. So something talking about the weight or the downward force acts on the ball, or we'd allow gravity pulls it down. The next part is it's going to accelerate, so the velocity or speed increases. And then there is drag that acts upwards, or air resistance, or air friction they'd allow. The drag increases with the velocity speed. So you can see as time goes on, you get faster and faster and faster and faster. And as you get faster, of course the drag goes up. And then if the drag's gone up, eventually drag will equal weight. Or we might say that they're equal and balanced. And then the marking point 6 talks about simply then, the resultant force is 0, or you could say drag take weight equals nothing. You rearrange your little formula, drag take weight, or D take air resistance, or something like that. At that point, the last marking point where you're here on the graph, you are falling at a constant speed, or the ball has 0 acceleration, or you might say we now have reached terminal velocity. Notice in the question they haven't talked about terminal velocity, so the big hint is that's a marking point. So 7 easy marking points. You've got to structure your answer chronologically in terms of time from start of the journey to the end. Talk about forces. So there we go, that's question 7 done.